Hello guys. Hello everyone. Welcome to Learn DSA with me. Today we are starting our journey into data structures and algorithms, commonly known as DSA. Before diving into programming concepts like arrays, linked lists, trees, it's important us to understand what DSA actually means and why it is considered one of the most important topics in computer science. In this video, we will learn what is data structure, what is an algorithm, and why DSA is important and how DSA helps us become better programmers. Now let's get started. What is DSA? DSA is combination of data structure and algorithm. DSA stands for data structures and algorithms. Before learning programming deeply, it is important to understand these two concepts because they form the foundation of efficient problem solving. What is data structure? A data structure is a way of organizing and storing data so that it can be accessed and processed efficiently. For example, imagine a library. Books are arranged in a specific order so that readers can find them easily. If books were placed randomly, finding a particular book would take much longer. Similarly, in programming, data structure helps us organizing data efficiently. We have some, after we will discuss some examples of data structures. And what is an algorithm? An algorithm is a step-by-step procedure used to solve a problem or perform a task. For example, if you want to search for a name in a contact list, you follow a sequence of steps. Those steps together form an algorithm. In programming, algorithms help us to search data, sort data, process information, solve complex problems efficiently. Now, we will discuss about few examples of the data structures. So here data structures are classified into two types, linear data structure and nonlinear data structure. Linear data structure means elements are arranged sequentially. Where data is stored in a linear order, each element has procedure and successor. So the examples are arrays, linked list, stacks, and queues. So these are linear data structures. Next category is nonlinear data structures. Here the elements are not stored sequentially. Data is organized hierarchically or as a network. One element can connect to multiple elements. Example, trees and graphs. And we also have some algorithms to search data, to sort data, and process information. Examples are linear search, binary search, bubble sort, and merge sort. We will get to know about this in further videos. Now, next one, understanding DSA with an example. Suppose we have the following numbers 10, 20, 30, 40, 50. These numbers can be stored in an array. So this is an array which is a type of data structure and these numbers are stored in this data structure. Suppose we have a target to find the number 30. The process used to find the number is an algorithm. So how we find this number? This is called an algorithm. Data structure is how data is stored. How data is stored in this data structure in the form of array. So array is a data structure. And how we are finding the target? By searching the element. So the algorithm is search. The data structure and algorithm together we perform to solve this problem. So here the array holds our numbers in indexed slots, making them easy to access and iterate over. The algorithm defines the steps. First it checks 0 index and then 1 and 2 until it finds the targeted element. Next, why DSA? First one is write efficient code. DSA helps us choose the right way to store and process data. For example, if you have 10 student records, any method may work. You can use any kind of algorithm. You will get an output within less time complexity and space complexity. But if you have more records, like 10 million, in that, if you use an inefficient approach, then your program will become extremely slow. So using the right data structure and algorithm allows the computer to perform tasks faster and more efficiently. If using binary search example, if you use binary search instead of linear search, you can reduce the time required to find an element significantly. Next one is reduce execution time. Execution time is the amount of time a program takes to complete a task. Different algorithms solve the same problem in different ways. Some are fast while others are slow. DSA helps us choose algorithms that require fewer operations. Example, linear search checks element one by one. Binary search repeatedly divides the search space into half. As the amount of data grows, the performance difference becomes huge. Third one is use memory effectively. Memory is a limited resource. Good data structures help store information efficiently and avoid unnecessary memory usage. Choosing the wrong data structure may waste memory and reduce performance. Example, arrays allocate memory in a fixed manner. Linked lists allocate memory dynamically as needed. Selecting the appropriate data structure helps optimize memory usage. Fourth one is improve problem solving skills. Learning DSA teaches you how to think logically and systematically. Instead of immediately writing code, you learn how to analyze the problem, break it into smaller parts, identify patterns, choose the best approach. This structured thinking is valuable not only in programming but also in real world problem solving. Fifth one, how to ace coding interviews. Most software companies evaluate DSA knowledge during the technical interviews. Interviewers want to see how to approach problems, whether you can optimize solutions, how well you understand algorithms and data structures. So strong DSA skills increase your chances of succeeding in coding interviews. DSA is not just about learning data structures and algorithms, it is about learning how to solve problems efficiently, write better code, and become a strong programmer. We have learned about what is DSA, what is data structures and algorithm, and examples of data structure and examples of algorithms. In next upcoming video, we will discuss about time complexity and big O notation. Stay tuned for the next video. Thank you.